In this video, we're going to take a look at rewriting log expressions using log properties. So for log properties, there are three main properties. They go along with our properties of exponents because exponential and log are inverses of one another. It would make sense that they coordinate. So for this first property we're going to look at, it's called the product property because they're multiplying. And when you're given something like this with the product, you need to expand it by giving each element the log. So it's log base b of m and log base b of n. When we're expanding, you give everything the log with the base. And then they were multiplying, so we need to add those two things together. So multiplying goes with adding. They look kind of similar. Then for the next property, it's the quotient property. So when we're given log base b of m divided by n and we're expanding that, you give each element the log with its base. So log base b of m, give log base b to n, but they're dividing, so you subtract. So think about dividing and subtracting actually look similar, like they're symbols. And the only other property we use for logs is called the power property. That's when you're given an exponent on what you're taking the log of. And in order to expand the log, you simply have to move that exponent out front. So it just goes out front to be called expanded. And when you condense it, you have to move it to the back. So let's look at a few examples of expanding the logs using these three properties. So for log base 2 of 3x, I need to write log base 2 of 3 and log base 2 of x. And then they're multiplied together, so I need to add. But then that's it. That's all I need. For number 2, I have log base 13 of 7y cubed. So I need to give log base 13 to the 7 and log base 13 to the y cubed. And those are multiplied, so I need to add. And then in my next step, I need to use the power property to move that power of 3 to the front, make it a coefficient. So I bring down log base 13 of 7, and now I have plus 3 log base 13 of y, and that's considered completely expanded. All right, moving on to number 3, I have log base 3 of x squared. So the only thing I need to do is move that power out front, so now it's a coefficient. And then that's the only thing I can do with that one. For number 4, I have log base 3 of 5x divided by 2. So I need to give log base 3 to the 5, log base 3 to the x, and log base 3 to the 2. Each one of those elements is considered a different part. And so you've got to give each one the log with the base of 3. So then 5 is being multiplied by x, so I add between those two. But 2 is being divided, so I need to subtract it. And then that would be all I need for number 4. Number 5, I have log of the square root of 3x. So what I would do first is say that's the same thing as log of 3x, and then that's to the 1/2 power would be the way you could rewrite a square root. They mean the same thing. So like the square root of x, in other words, equals x to the 1/2 power. You have an inside number of 1 and an outside number of 2. So they go together as a fractional exponent. So then what I can do is distribute the 1/2 power so that now I have log base 3, log of 3 to the 1/2, x to the 1/2. And then we could rewrite that with log of 3 to the 1/2, and then it's multiplying by x to the 1/2. So we need to add it and say that's log of x to the 1/2. And then in the next step, we have to move those powers out front. And that would be our final step in expanding this log expression. So we have 1/2 log of 3 plus 1/2 log of x. And that's it. Number 6, we have natural log of 2x over 3y. So we have natural log of 2, natural log of y, natural log of 3, and natural log of y. Or excuse me, I meant to put an x right there. So natural log of 2, natural log of x, those are being multiplied in the numerator. So I need to add between those two. But then the 3 is being divided and the y is also being divided. So you think about what's happening to the 2. So just focus on that first element. 2 is multiplying x, or it's in the numerator. So you've got to add. But then 3 is dividing the 2, so you have to subtract. And then y is also dividing the 2, so you still have to subtract. You can also think of add the things that are in the numerator and subtract the elements that are in the denominator. And that works every time to keep it straight. All right, so now let's go in the reverse order. If we're given expanded form and we want condensed form, that means we want to put them together. So using the same properties, the first one is the product property. They are adding, so I need to multiply. So I'll put a log base b of m times n, but just one log base b because you're condensing them into one log expression. For the second one, they're subtracting. So I need to write log base b of m divided by n. Again, just one log base b, but then you divide the two elements. And then you have the power property. So the c just needs to become an exponent again on the m. So that would be log base b of m to the c power. But then that's all you need for the power property. So let's look at a couple of examples of condensing log expressions. So if I have log base 4 of 10 minus log base 4 of 5 plus log base 4 of b. You start by writing this first one down. So log base 4 of 10. And then it's subtracting log base 4 of 5. So put the 5 at the bottom. And it's adding log base 4 of b. So put the b at the top. So when you subtract, put it in the bottom or divide. And when it's adding, put it in your numerator or multiply. Then we could do that, a little bit of reducing there. So log base 4, 10 divided by 5 will give us 2. So you can reduce it to be log base 4 of 2b. You might see it that way, or they might leave it unreduced. It just depends. But number 2, let's look at this one. We have 3 log base 4 of x minus 2 log base 4 of y. So first I just need to move the exponent back. It's the last thing we do when we are expanding, but the first thing we do when we're condensing. So I have log base 4 of x cubed now minus log base 4 of y squared. And then those are subtracting. So subtracting goes with dividing. So write the first one down and then divide by just the y squared, because you only want to write one log base 4 since you're condensing them. All right, 2 more examples. Number 3, I see I have a 5 out front and a 3 out front. So first things first, we got to move those to become exponents. Then they're adding, so we need to multiply. So we have natural log of a to the 5th times b cubed, but just write it one time, the natural log, and that's it. And the last one, number 4, I see we have numbers in the front, so the first thing to do is move those to become powers again. So we have log of 2 cubed minus log of 4 to the 1/2. So that would be log of 2 cubed divided by, since they were subtracting, and we have 4 to the 1/2. Now, on a test question, they could leave it like that, but we can also reduce it and get something more simplified. So 2 cubed would give us 8. And then 4 to the 1/2 power is the same thing as the square root of 4, which is 2. And then log of 8 divided by 2 is the same thing as log of 4. So again, they could leave it just as it is, or they could reduce it. It just depends on the question. All right, so that's it for log properties.